G'day viewers, this is Troy from Troy's Visual Arts channel. Got some really good news. Realising that directly driving the motor from the power supply, I'm getting copious amount of current flowing through the motor and literally blowing up the fuse inside. Yep, it was a blown fuse. Yep, blown a 10 amp fuse. How about that? Must be something, you know, enormously in excess of 10 amps that was going through that motor when I directly drove it. Well, now I've fixed the problem, replaced the fuse inside the power supply, and I'm realising that, yeah, the load resistor, you know, really limited the current pretty well to enough to properly drive the motor. I realised that, yeah, when I had the power supply directly hooked up to this little power unit here, and the amount of current that was flowing through the TIP31 transistor was, you know, enormously high and over its max rating, and yeah, blew the arse out of it. If I can get a close up of it, see that, yeah, you can see it's pretty well blown open at the front. Poor little high powered transistor couldn't take the current. Anyway, on with the video, getting straight to the point of it all. Yeah, after having this load resistor in series with this speed control unit, it is now working. So powering it up, it'll be quite slow to start. It has to overcome a bit of inertia. I had to give it a bit of a helping hand. So yeah, this circuit is comfortably handling the amount of current that's needed to go through this circuit. I've currently got the voltmeter hooked up to the motor. It's only running off about 0.44 volts DC, but still it's enough to drive the disc quite nicely. And so we're only dealing with such low voltage but high current, of course. With this speed control unit, I can get a speed control between about 0.4 something volts and about 0.7 volts DC. Makes it run quite nicely. So yeah, I'm glad I fixed that issue, so I now can use this coarse speed control unit to adjust the speed of this disc. And then of course I'll have the fine speed control, which will be powered from this BUZ71 transistor, also sitting on the heatsink. And got to find the schematic, and it'll be powered from another trim pot of a value of 200 kilo ohms, and which connects to the gate of the BUZ71 transistor. So basically, yeah, hooking that up, and I can fine tune the speed of the disc. And of course it'll be also controlled from the 4046 chip, which will further synchronize the speed to a consistent speed to synchronize with the NBTV standard from that 4046 chip and the 400 Hz crystal clock, and of course a few other bunch of other components as well, you know, that are associated with the speed control. and of course the sync will be picked up from that encoder disc circuit. I've actually forgot to mention in the previous video, as part of the update, I've now glued on the opto pickup sensor that sits in front of the encoder disc in position so it will pick it up. Hopefully I've got it in the right position so we'll pick it up properly. I have to do a bit of testing with that. If it's not right, I'll have to move it back, a bit back or a bit forward, something like that. But it's glued in position. I've detached the leads, of course. I've got to reattach them and get the little encoder circuit put into place. Anyway, yep, that's also what I've done with this NBTV camera. Anyway, the main thing is yeah, get the speed control right. Phone call, stay tuned. Sorry about that, just been interrupted with a phone call. Now back on with the video. Just trying to think where I was at last. Yeah, I was getting back onto the speed control. So yeah, the speed control is working all right. The resistor, of course, is still heating up pretty much. It's still a big load for the resistor to handle, although the resistor is not smoking anymore because the TIP31 transistor is taking some of the load, which is good. Actually, it's not. I can see the bloody the heats, the washer's actually starting to melt. So got some issues here. Yeah, it's still a bit much, but the transistor still seems to be working. Anyway, yeah, still going to have to find a way to overcome this high power issue. I might have to actually put a much more high powered transistor in place of the TIP31 so that way I can handle better to the high current. We'll keep at it, but so far it's good news that it's at least working better. Now they've got the load resistors in place instead of run it directly from the power supply, which, as seen, blew the arse out of the transistor. Anyway, bit better news this time. I'll keep you updated when I put a high power transistor in place of the TIP31. Stay tuned for the next video. This is Troy from Troy's Visual Arts channel, signing out.